In this lesson, we will start talking about object-oriented programming, specifically objects and classes. So objects represent things in the real world. They could be a person, they could be a geometric object like a circle, they could be anything, even an online order. They are made up of two things. They are made up of state and behavior. State of an object are its attributes. So these are the member variables of the object. Behaviors are objects' actions that it can perform, and these are really the methods of the object. Now let's talk a little bit about the term class and object. The term class is used to refer to the template or the blueprint that is used to create objects, whereas an object is an instance of a class. So for example, you might define a class called circle, but you might have two different circle objects, each with a different radius value, one with 2 and one with 100. Right? So the word instantiation refers to the act of creating the object. Right? Each object is an instance of the class. So above we had two instances of the class object. Now you can create objects by using some special methods called constructors, which we'll look at in a bit. So actually let's look at a real example, right? So I was speaking about a circle object. So this is what the definition of a circle class would look like, right? So we're used to class definitions before. We've done that. To write any Java program, you need to create a class definition, right? So let's look at what this class definition has. It has some amount of state represented by its attributes. So in this case, we have a member variable called radius. Then it's got a bunch of actions that can be done, which are the methods. There are a couple of special methods called constructors, which we will talk about in detail. And then there's some other methods that are used to get the area or get the perimeter or set the radius of the circle, right? Now, one thing you'll note is there is no main method here, right, which we're so used to. So that means this class can't be run by itself. It will need another class with a main method to have it be runnable, right? So we will actually do that in a little bit. But the next thing I want to introduce is this notation called UML diagrams. So UML diagrams allow us to visually represent class hierarchies and class relationships, right? So this is the one for the circle class above. So at the top, it's got the name of the class. In the middle, it has the member variables. And at the bottom, it's got the methods. Now, the notation here is a little bit different. It's got the name of the variable or the method first, and then the types afterwards. Same goes for parameters, right? So that is something that we'll just have to kind of get used to. There are no modifiers shown here, such as public, private, or protected, or static here, but we will get to that a little bit later, right? So let's talk about these special methods that we call constructors. So these are methods that are used to create an object from the class definition, right? They have to follow a couple of rules, and let me talk about it, and then we'll look at the code. First, the constructors the methods have the same name as the class. The second, they don't have a return type, and they are used by using this operator called new, right? You can have multiple copies of constructors, so they're overloaded methods. And the last thing I want to say before we look at the example is that if you don't have to have a constructor. If you leave it out, one is transparently created. It's a default constructor. has no arguments and no body, right? So let's look at the constructors that we have here. So the first thing I'd said is that the constructors have the same name as the name of the class. They don't have a return type. They don't even, it's not even void there. There is really nothing there. And now let's look at how we use the new operators. So let's go a little bit further down. So here is a main class. I remember I'd said that to use the circle class, you could not run it by itself. You needed another class with a main method to run it. So I have defined another class. It does have a main method. In the main method, I have created 3 variables of type circle, and I'm using the new operator to create objects of that type. Right? I'm calling the constructors in each case. There are 2 constructors, 2 types of constructors. So here I'm calling the one without any arguments. For the other 2, I'm calling the one that takes the radius as a variable. So what's happening here is 3 objects are getting created, each with its own copy of radius with different values, right? A couple of things to say here is that circle 1, circle 2, circle 3 are reference variables. So they are pointers to locations in memory. That's different from primitive types, which are the actual value, which hold the actual value. Right? The other thing to say is, now where do I put, what files do I put my program and the circle class definitions in? Do I put them in separate files? You can, but you can also put them in the same file. In this case, you will put it in a file called myprogram.java, right? So only one class in that file can be public, and that name has to match the name of the file, right? So in this case, only my program is a public class. So the file will be called myprogram.java, right? Now, even there's only one file that is called myprogram.java, you will notice when it gets compiled, it is still going to produce 2 .class files. You'll see circle.class and myprogram.class being created. Now, the last bit of information we want to give before we actually run this code is, well, how do you call these methods, and how do you call these, how do you access these member variables? So for that, we use something called a dot notation. Essentially, to get to a member variable, you would have a dot followed by the name of the variable. To invoke a method, you would have a dot followed by the method. And you can see that here I'm printing the radius of circle 2, and I am calling getPerimeter on circle 3. Again, these variables are reference variables. So if you pass them into methods, they are passed by reference. Locations are being passed. So there is a notion of primitive types such as Boolean double, and then there are reference types which are arrays and objects. The last thing to note here is that even for the primitive types, there are corresponding class definitions with a capital B for Boolean, capital C for character and such, that provide additional methods. And if you are using these data types, they are passed by reference, so just be aware of that. So with that, let's look at some code. We will open up IntelliJ. So let's talk about this. So notice I have a single program file called myprogram.java. Now I can put 2 class definitions in there. There is the circle class, and then there is the myprogram class. Now only one of them can be public, and that is the one that is used for the name, right? So this is the same code as I provided earlier, and in the myprogram class, I do have the main method, which is creating 3 variables of type circle, and making objects using 2 variants of the constructor method and then printing a radius of one and getting the perimeter of the other. Let's compile this and run this. So what it's printing is two things, the radius and the perimeter. Now one thing to note is even though this is a single file, it does create two variables, a circle.class and myprogram.class, one for each of the classes we have in our file. Let's close this. So far, all of our member variables have been something called instance variables, right? So these are variables where each object has a copy of that variable. So for a circle, there was a copy of the radius variable within each of the objects. Now, by contrast, static variables declared with the static modifier are not instance variables, but they're variables shared by all the instances. There's only a single copy of them, right? They can really be thought as belonging to the class, and in fact, we represent them as such as not within any of the objects, but really held by the class, right? So if any of the objects in their methods modifies it, they're modifying a common copy and would be reflected to everybody else, right? So just like we have member variables that can be static, methods can also be static. And now where have we seen static methods? We've already seen that. And the answer is static methods are seen within main classes. The main method is a static method. Now what does it mean to be a static method? So static method can be called without actually creating an object of that type, right? And that's why we can use main the way we use it, right? Now, static methods have a restriction that they can't refer to any instance variables, right? Because they are may be used without actually creating the objects of the instant variables may not really even exist. So let's look at an example of how we might use it. One very common use case would be to count the number of objects of particular type that are created. So suppose we want to keep a count. Every time somebody creates a circle object, I want to keep a count of that. So how would you do that? So in the circle class, you would create a static variable. Let's call it circle count and initialize it to 0. And then anytime a constructor is called, you would increment that variable, right? That's a good way of keeping count. And then you might want to provide a method to get at that, and that would be a static method, right? Because returning it can't reference any instance variable, but it can reference static variables, right? So then how would you use it? How would you access these static members and static methods? So any of the following are okay. So you can use an instance of circle and refer to the static variable, or you can actually use the class name and refer to the static variable, right? But this is a better use case because it shows that this is a static variable that's being used. Similarly, you could use it in the same way for methods. You can use it on an instance or the actual class name, and of course the second one is better because it shows it's a static method that you are calling. Okay, so then how is this reflected in UML diagrams? Now you have a new type of variable. So static variables and static methods are underlined. So that's how you tell in a UML diagram that these things are meant to be static. All right. Now we move on to other types of modifiers. Now we can control visibility of classes, methods, and variables by using special modifiers called public and private, right? So if we're using public for classes, methods, and variables, they are accessible to anybody, right? They're completely open. right? And if you're using private, they are all, for methods and variables, they are only accessible within that class. They are not visible to the outside world, right? Now you can also leave out the modifier, and if you leave out the modifier, then they are accessible within the package that holds that class, right? That's the rule. So how should you use it? What are good guidelines? The good guidelines are, you want to make all your variables, member variables, private, right? And provide getter, and setter methods to, to access them or modify them, right? So what would we do for the circle class? So here is how I have shown it. You would want to make your member variables private, and we'll get to why we do that and why this is a good policy in a future lesson. And everything else is made public, right? So what does this look like in the updated UML diagram? So the thing you'll notice is now we have a minus in front of things that are private, and we have plus in front of things that are public. Now, not all methods need to be public. You might have some helper methods that you want to keep private. So you can also have methods that are private, right? Now, before we move further along, let's actually try this out, the use of static methods and static variables. So we will take this updated definition and put it in IntelliJ. We'll replace our previous definition with this one. And then let's just copy a use of it. So here's how we were using it. All right. And we'll go back to IntelliJ, and instead of printing the perimeter, we will see, well, how many circles are we creating? And let's get rid of this thing, because it was made private. The radius is no longer accessible. That's why we were seeing the red earlier. And so if this goes well, we should print 3. All right, let's close this. Now, there are only a few more things we want to talk about to complete our knowledge of classes and objects. Now, as I'd mentioned earlier, objects are passed by reference to a method, just like arrays. You can declare arrays of objects. You can declare an array of circle objects, right? And interestingly enough, class variables and methods are available for use in the entire class, regardless of where they appear. So this is a little different from the notion of scope that we might be used to, where a variable needs to be declared and then it can be used. Here, a class variable is available to you anywhere, regardless of where it appears in the class. You can have a variable at the end of the class and still use it in earlier methods. Okay. Now there's this concept of an immutable object, right? So an immutable object is one that can be changed, can't be changed once it's created, right? So you can define a class and kind of enforce this behavior by the methods that you provide. An example of one is string. Once a string is created, it is cannot be changed. It might seem like you're changing strings by appending to it, but it's really a new string is being created. Okay. Now the last concept that we want to talk about is the new keyword called this, right? So the this keyword is used to can be used by an object to refer to itself. Now, why would you want to do that? Sometimes you do have to do that. If you want to call a different copy of your constructor. So let's look at an example. So here I have the class. I have 2 constructors, right? I have a constructor with no arguments. But what I want to do is, if someone calls this, I don't want to leave radius as undefined. So I want to call another constructor that does have that value and give it a default value. So by saying this, I'm really referring to my other constructor, right? Another use case might be that because of how you are using parameters, sometimes your member variables get hidden. So here I have a member variable called radius, but in this constructor I have an argument called radius. Now within the scope of this method, if the radius is already being used as the name of the argument. So how do I refer now to my member variable that is radius? So you can do that by saying this.radius to explicitly refer to the member variable. All right, so this has been the lesson on object-oriented programming, specifically objects and classes and how to use them. All right, thank you.